Hi, and welcome to this OpenTopography tutorial. Today I'm going to show you how to read in and visualize Lidar point cloud topography data in Matlab. In this demo, we are going to use Matlab's Lidar Toolbox, and this can be downloaded along with the academic license to the 2022 and later versions of Matlab. Now, this Lidar Toolbox is a really powerful tool for working with Lidar point cloud data. Today's demo is really just an introduction. If you're interested, I invite you, of course, to learn more looking at many of Matlab's documentation pages on this toolbox. So today we're going to be looking at this script here that I wrote for Matlab. It's called Point Cloud Matlab, and you can download it from OpenTopography's GitHub page, which is listed in the comments section of this video. And in this tutorial, we're going to be looking at a point cloud data set that is can download from OpenTopography, and it covers the Utah State Capitol building in Salt Lake City. Of course, you can use any other point cloud data set that you would like. And so, just very quick reference, this data set can be downloaded by following the link put in the Matlab script, and that will then take you to this page for this Utah State data set. And here we're looking at the Utah State Capitol, so it'll end up being a fairly modest size point cloud data set. And OpenTopography's default for downloading point cloud datasets is in this LAZ format, and this is the compressed format. If you have an older version of Matlab, for example, or you cannot download the Matlab Lidar Toolbox, then we do have another video that walks you through how to open the LAS format file in Matlab. So you can generate an LAZ file, for example, using this OpenTopography data job, or you can feel free to use one of your own point cloud data sets. So here's the script, and we're going to go over the several parts of the script to learn how to open and visualize a Lidar point cloud data set in Matlab. So the first main part of the script is shown here. And in line 12, we initialize a point cloud reader. And then in line 13, we read in that point cloud data set. And here I'm reading in the file that I've called Utah State Capitol.laz. So this is an LAZ point cloud data set, and I downloaded it from OpenTopography and then renamed it something so that I can locate it easily in the future. So we'll run that. Takes a few seconds. So then let's learn about the point cloud file that we just loaded. So here we see point cloud. It's a point cloud file with the following properties. So this data set has location, and that's about 3.5 million points times 3. 3 is for X, Y, and Z coordinates of the data set. The count here is about 3.5 million, again, reflecting the number of points in the data set. Here are the X, Y, and Z limits of the data set. Just my knowledge of the area suggests that these are UTM coordinates with elevation in meters. This data set is one of a relatively few number of Lidar point cloud data sets that has color, and this data set has number of points times 3 for RGB, and then this data set also has intensity. So in the Lidar Toolbox, there's a very nice way of plotting the data set, and that's in PC Show. and then point cloud dot location. So let's run this line. So this is going to show us our point cloud data set with the points colored by elevation. And so here we can clearly see the 4 buildings that constitute the part of the capital for Utah, and then also see trees that border the area. We might also be interested in plotting the point cloud by color. So we can run this line to extract the color information. And this point cloud dot color is using the Matlab data structure format to extract the RGB color information. We can then also use PC show in this case to color the point cloud by the RGB color. So here we see the same data set. Now we have additional context for what the landscape looks like. In particular, we can see these 4 main buildings in the area, some parking lots with parked cars, as well as a few roads that border the capital. Another really interesting thing that we can use in Matlab to learn about the point cloud is this classification information. So that's last reader dot classification info. And what we see here is information about the classified points. So we see that in classification 1, which constitutes unclassified points, we have just over 2 million points. Points with classification value 2 are ground points, and that's just over 1 million. And there's a few noisy points here with classification value number 7. We can then also plot the point cloud with just selecting 1 or 2 classifications. So in this first plot, I will plot points that are just classification 1. And so these are going to be the unclassified points. So in this case, again, we're looking at the unclassified points, and we can see the building of the Utah State Capitol, as well as some of the vegetation that surrounds the building. And again, these points are essentially just not classified as ground. In the next set, we can plot points that are classified with classification value 2. So these will be the ground points. So in this case, we see the capital area, but the buildings and vegetation have been clearly removed. And so we just see the bare ground. And one thing you might be interested in doing for subsequent analysis, for example, 3D differencing, is to extract the vectors for the X, Y, and Z coordinates. And that's done here. So I do points equals point cloud dot location, whose points. So now I see that points is this matrix that's about 3.5 million points long times 3 for the X, Y, and Z. And then if I want simple vectors with the X, Y, and Z data, then I can extract them in that way. So thank you. This concludes OpenTopography's tutorial on how to read and display point cloud data using Matlab's Lidar toolbox.